Assalamualaikum. We are from Group 7. Our group will present about design of OfficeIntelligen Lightning based on Arduino. We have 5 members in our group, which is Aiman, Azrul, Fikri, Diana and Farah. First of all, introduction. Measurement system, any of the system used in the process of associating number with physical quantity and phenomena. In the past, they were just for fundamental measurement, which is mass, distance, or length, area, and volume. Today, the idea of width and measure also take into account aspects like temperature, brightness, pressure, and electric current.
Purpose: design of OfficeIntelligen lighting system based on Arduino. This report is related to the existing issues with energy waste in China's office lighting, which is lack of intelligent lighting control, and single adjustment mode based on domestic intelligent control system stage of development, current stage of technologies, and other factors. This study suggests using an Arduino as the primary controller in combination with an infrared inductive sensor, a light sensor, and a Wi-Fi network as the method of communication. The delay, turn-off control, and dimming functions can then be automatically realized in connection with the sensor's detection condition, realizing the detection of the office lighting environment and enabling control and adjustment of the office lighting fixture. The purpose of the system is to have cheap costs and low carbon emissions, both of which are highly effective for an office environment. Next, we move to another slide. It's about physical variables. The physical variables is the parameters that represent the physical quantity, attributes of physical objects. The parameters measured by using the sensor. Arduino is the sensor that used to measure the parameter in the lighting sensor in this project. Arduino used to detect and adjust the voltage and current amplitude. Based on the Arduino Intelligent Office Lighting System, the parameter used in this system is current and voltage. It is used cutting-edge electromagnetic voltage regulation and electronic sensing technology to track and monitor power supply in real time, automatically and smoothly adjust the voltage and current amplifier of the circuit, and reduce the additional power consumption brought on by unbalanced load in the lighting system. Besides that, temperature is designed to automatically control the opening and closing the lamp. Temperature adjusts the brightness of the lamp and set the scene function for the office staff. The most satisfying visual effect. Through prudent administration, the intelligent lighting control system built on an Arduino may give us the most comfortable illumination. The office energy use can be decreased by using the least expensive energy possible in both work and daily life. In addition, it broadens the range of applications and offers research proposals for sensor detection and electronic sensing technologies. Next, sensitivity. Sensitivity is used in the illumination sensor. A 16-bit digital to analog converter is integrated within the module. Without doing laborious calculations, it can output a digital signal directly. The illumination sensor uses the thermoelectric effect as its guiding basic. The principal detecting element of the sensor has a great sensitivity to low light. The output signal is proportional to the level of ambient light in the linear range. The visible light that passes through the filter is the irradiated to the imported photodiode, and the photodiode can convert the brightness of the visible light into an electrical signal until the electrical signal reaches the processing system of the sensor. The sensor generates the binary signal that will be obtained. Movement is also used in this system. When a human body moves into the range of the sensor, the system output is a height level. However, if the human body keeps moving, the height level of the sensor stays valid until the human body departs the range of the sensor detection, at which point the height level changes to a low level. Next slide is about measurement system element. From the figure shown in the slide, we could see the figure of element of measurement system. Different sensors in the system are placed together, combined with the infrared inductive sensor and the light sensor with the controller in the room. The system proposed to adopt Arduino as the main controller. The primary sensor and variable conversion element are combined, and the combination is known as the transducer. The indoor parameters detected by different detection devices are transmitted to the user through the Arduino controller. The Arduino microcontroller is not responsible for collecting data. It is only responsible for transmitting the data collected by each node to the system through the communication network. Arduino is responsible for the acceptance and processing of data and transmit it to the LCD for display according to the relevant attributes of the data, then uploads it to the client data center through the communication network.
For build materials, the components that required to build the measurement system for design of OfficeIntelligen lighting system based on Arduino, which is the component that used in this system Arduino as a controller, inductive sensor, light sensor, and Wi-Fi network as a communication mode and delay, turn-off control, and timing function. Arduino microcontroller is responsible for transmitting the data collected by each node to the system through the communication network. Arduino is an open-source electronic platform based on easy to use in hardware and software. Moreover, an inductive sensor is a device that uses the principle of electromagnetic induction to detect or measure the object. In this design, the passive infrared sensor is being used, which is a HCSR501 type of infrared sensor. It is to measurable the analog voltage or sometimes a digital signal. The light sensor also has been used in this design, which is a BH1750F type of light sensor. It is a digital ambient light sensor IC412C bus interface. You can adjust the brightness of the screen according to the external light conditions. Moreover, the Wi-Fi network is selected as the carrier for transmitting and receiving the data. The ESP8266 is an ultra-low power watt Wi-Fi chip designed for mobile devices and IoT applications.
Explanation of block diagram. Number 1. Arduino microcontroller. As the central process unit of the system, it receives input from various sensors and control the LED light accordingly. Number 2. Light sensor. This sensor detects the ambient light level in the office. They can be photoresistor or ambient light sensor. The sensor data is sent to the Arduino for processing. Number 3. Control algorithm. The Arduino run an intelligent control algorithm to determine the appropriate lighting level based on the input from the light sensor. This algorithm can be customized to adjust the lighting based on factors such as occupancy, time of day, or as preference. Number 4. LED light controller.
This component receives command from the Arduino and control the LED light accordingly. It can be a dedicated LED driver or a relay module that turns the light on or off or adjust their brightness. LED light. These are the actual LED light installed in the office. The Arduino sends control signal to the LED light control to adjust their brightness or turn them on or off. Number C. Human interface. This can be a physical user interface such as button or switch, or a digital interface such as a touchscreen or mobile app. It allows users to interact with the system, providing manual control and configuring system.
OfficeIntelligen lighting system is a transducer which is convert one from energy from one to another. Sensor is device that sends a physical stimulus and convert into a signal. The sensor signal can be any measurable physical characteristic. OfficeIntelligen lighting system use infrared sensor as sensor, light and LCD display as actuator. In the meantime, this system processor is an Arduino. The indoor parameter detected by different detection devices are transmitted to the user through the Arduino controller. The signal conditioning process in a lighting system based on Arduino can be modified in various ways depending on the specific requirement. Here are a few common modifications that can be made. First, voltage level, stepping. Second, filtering. Third, amplification. And then isolation. And lastly, calibration. So now what is the signal conditioning? The signal conditioning in an intelligent lighting system based on Arduino. Signal processing refers to the competitive or manipulative operation, conforming on the incoming signal to achieve specific objective. This is list example of signal processing tasks commonly performed in system: sensor data processing, feedback control, adaptive lighting, signal filtering and noise reduction, and signal compression, and then pattern recognition.
In conclusion, this system is often focused on the energy conservation, cost reduction, and safety enhancement and simple maintenance for the system in the future. It also basically completes the initial verification and feasibility of the office lighting system and from the hardware. So the software main purpose has likewise been attained. This system will be extremely significant and serve as a valuable resource for field research and industrial actualization of future intelligent control lighting for offices.